Good morning, children. I believe you all are well and safe. We successfully completed 3 lessons. 6 sessions are over. In this session, I am going to teach you a new lesson. Now we are going to enter a new chapter, Analytical Chemistry. In this lesson, we are going to discuss what is analytical chemistry and its types. What is the use of this analytical chemistry? What is analytical chemistry? First, we are going to know what is analysis. Determination of the chemical components in a given sample is called analysis. Yes, here in the chemical compounds, to separate without knowing the compounds present in the given sample, with the help of these analytical chemistry, we can separate the compounds based on its properties. In this analytical chemistry, we have a types: classical analysis, instrumental analysis. Classical means it's a old method to analysis. Instrumental analysis means with the help of the instrument, we are going to find out the compounds. Next, these analysis, again we have two types: qualitative analysis and quantitative analysis. Qualitative analysis, we know the quality, to find out the quality of the compounds present in the given sample. Quantity means how much quantity of the given sample the particular element is present. So these things we are going to discuss briefly through this lesson. The first type, qualitative analysis. In chemistry, qualitative analysis is the determination of the chemical composition of a sample. It encompasses a set of analytical chemistry techniques that provides non-numerical information about a specimen. Quantification of sample, in contrast, is called quantitative analysis. Here, qualitative analysis, so how much of the quality of the particular chemical present in the given sample, only we are going to discuss quality. It is not measuring a quantity, how much of measure of the sample given. Next, quantitative analysis. Quantitative analysis, which involves the determination of composition of a mixture. Yes, here when they given a mixture, how much of particular element, for example, we have acetic acid, in that formula CH3COOH. So if they given the sample, that doesn't telling what is the compound given to you. You have to find out how much carbon is there, how much hydrogen and how much oxygen. Like that, we need to find out quantitative analysis in the analytical chemistry. Colors of the salt and their solutions. Here we are going to see the periodic table elements and their colors. First, the representative elements. These elements are present in the group 1, 2, 13 to 17 are generally colorless. These are the representative elements or colorless in nature. Next, transition elements are the group 3 to 12 are generally colored. So, maximum the transition elements are colored in nature. Next, some of the ions we have a colorful and colorless. Here colorless ions: ammonium, aluminium, zinc, calcium, copper, chromium, iron 2, iron 3. These are the cations. They doesn't have any color, seems to be colorless. Next, we have a colored ions also. See, scandium, titanium, vanadium, chromium, manganese, iron 2 plus, cobalt, nickel, copper and zinc. These are the ions possess colors. See, maximum here we have a transition element ions. Colorless and colored anion. Previously, we saw colorless and colored cation. Here, some of the anions: carbonate, chloride, bromide, iodide, nitrate, sulfate, and sulfite. These are colorless anions. And next, colored anions: chromate, dichromate, and permanganate. These are the three anions have color in nature. Precipitation. Precipitation is the process of formation of an insoluble solid when solutions are mixed. For example, when a silver is mixed with chlorine, it forms a silver chloride. When this solution, this silver chloride is settled down at the bottom, we can say it as a precipitate of sodium chloride. That is the insoluble solid settled down at the bottom. We can say that one as a precipitation. Here we are going to discuss action of sodium hydroxide solution on certain salts. So what will happen when sodium hydroxide is reacting some of the salts? First, we are taking calcium salt. When the calcium nitrate is reacting caustic soda, the calcium hydroxide is precipitated, it is white in color, and corresponding it is giving sodium nitrate, it's a colorless. Why it is forming sparingly? It is very less insoluble. Next, the iron salt. First, iron 2 salt, ferrous sulfate is reacting caustic soda, that is sodium hydroxide. Ferrous hydroxide has been precipitated. Its color is dirty green, gelatinous precipitate. Gelatinous, somehow it is sticky in nature. And then sodium sulfate, we are getting colorless. It is insoluble, totally it is insoluble. That's why we are getting a gelatinous precipitate. Next, ferric salt, that is iron 3 salt. Ferric chloride is reacting caustic soda. Here, ferric hydroxide has been precipitated. It is giving a reddish brown precipitate, and then sodium chloride salt is formed. It is also insoluble. Copper sulfate is reacting sodium hydroxide. Copper hydroxide has been precipitated, and then sodium sulfate salt is forming. Here, the copper 2 hydroxide is forming a pale blue precipitate because of insoluble in nature. Next, zinc salts. When the zinc sulfate is reacting sodium hydroxide, it has been giving zinc hydroxide. Then sodium sulfate. Here the zinc hydroxide is white gelatinous precipitate because it is not soluble. When we add a excess of sodium hydroxide, it becomes a sodium zincate and water. So it is forming a salt, and then we are getting a water. Next, lead salt. Lead nitrate is reacting sodium hydroxide, and then lead hydroxide has been precipitated. It is white in color, and then sodium nitrate salt is forming. Here also, when we add an excess of sodium hydroxide, the lead hydroxide becomes a sodium plumbate and water comes out. Here, when the excess amount of sodium hydroxide we are adding to it, it is forming a salt and water like a neutralization reaction. But in the case of very little amount when we add, it has been precipitated. Action of ammonium hydroxide on certain salt solutions. Here, the ammonium hydroxide is added dropwise to the solution of metallic salts. Precipitates of the hydroxide are formed, which are identify the distinct colors. Because the different colors precipitated, we are going to identify the salts. Some precipitated metallic hydroxides are soluble in excess of ammonium hydroxide because of the formation of soluble amino complexes on further reaction with excess of NH4OH. The same thing what happened to the sodium hydroxide, likewise here also happening. When limited amount of ammonium hydroxide when we are adding, it is forming a insoluble salt that is precipitated, Again, when we are adding an excess amount, it is forming a salt plus water. First, iron 2 salt. Iron, ferrous sulfate has been reacting ammonium hydroxide. The ferrous hydroxide has been precipitated. Here it is producing a dirty green precipitate. Again, ammonium sulfate salt has produced. It is insoluble in nature. Next, iron 3 salts, that is ferric salt. Ferric chloride is reacting ammonium hydroxide. Ferric hydroxide has been precipitated. Here it is reddish brown precipitate. Again, ammonium chloride salt also formed. It is insoluble in nature. Next, ferric sulfate, again it is reacting ammonium hydroxide and is giving ferrous hydroxide. It is reddish brown precipitate and then forming a ammonium sulfate salt. Yeah. Copper sulfate reacting with ammonium hydroxide, it is precipitating copper hydroxide. It is pale blue precipitate and then forming corresponding ammonium sulfate salt. It is soluble in nature with the excess of sodium hydroxide, so it is forming a tetraamine copper 2 sulfate. When we are adding a excess amount of ammonium hydroxide and then it is giving out a water, so it's like a neutralization reaction. When we add the excess amount of ammonium hydroxide, it is giving on salt plus water. This reaction is a characteristic property of Cu2 plus ion and is used for its deduction in qualitative analysis. So it is a specific reaction to identify a copper salt in the analysis. Next, zinc salt. Here zinc sulfate is reacting ammonium hydroxide forming zinc hydroxide. It's a white gelatinous precipitate and then forming a corresponding ammonium sulfate. It is also soluble when we add an excess amount of ammonium hydroxide. It is forming a tetramine zinc 2 sulfate solution and then water. The same manner the zinc chloride is reacting ammonium hydroxide. The same zinc hydroxide has been precipitated. Again the excess amount of ammonium hydroxide is reacting. It is forming a tetramine zinc 2 chloride. So excess amount, this copper and then zinc salts are giving a new salt as well as water. Next, lead salt. When the lead nitrate is reacting ammonium hydroxide, lead hydroxide has been precipitated. It is chalky white precipitate and then ammonium nitrate salt is produced. It is insoluble. Only the copper and zinc salts soluble in excess ammonium hydroxide. The remaining salts won't soluble in the excess ammonium hydroxide. It has been forming a precipitate. Next, we are moving to the topic action of alkalis on certain metals. Alkalis, you know, it's a base. Alkali metals like zinc, aluminium and lead react with odd concentrated caustic alkalis. That is, either it may be a sodium hydroxide or potassium hydroxide to give soluble salts and liberate hydrogen. The previous two, that is ammonium hydroxide and sodium hydroxide reactions, we are giving a sparingly soluble and soluble insoluble precipitated, but here it is giving a soluble salt and hydrogen gas has been liberating. The first thing, the zinc metal is reacting caustic soda. When the reaction is take place in the hot condition, then it is giving a sodium zincate, hydrogen gas has been liberated. Next, the same zinc metal is reacting potassium hydroxide. When the temperature is given, it is forming a potassium zincate. Again the hydrogen gas has been liberated. Next, the aluminium metal, it is reacting caustic soda and then water. It is giving out sodium aluminate and hydrogen gas. Aluminium reacts only with boiling and dilute alkalis. Yes, when the dilute means when we add the alkalis to the water, then only the aluminium can react with the alkalis. Next, aluminium is reacting potassium hydroxide and water. It is giving out potassium aluminate and then hydrogen gas has been liberated. So only aluminium metal is reacting to the dilute alkalis, not a concentrated one. So here also we are not giving out the temperature. Next, lead. Lead is reacting sodium hydroxide giving sodium plumbite and hydrogen gas. And the same, it is reacting potassium hydroxide and giving potassium plumbite and hydrogen gases comes out. Our next topic is action of alkalis on metal oxides. We already know many metal oxides are basic in nature. These metal oxides and hydroxides neutralize acids but do not react with bases. Yes, we already know these bases neutralize with acid and giving corresponding salt plus water. See, sodium oxide is reacting water to give sodium hydroxide. Then this sodium oxide is reacting with acids, hydrochloric acid, giving out corresponding sodium chloride and then water. So it is undergoing a neutralization reaction. A few metallic oxides and hydroxide exhibit dual character. Yes, dual character means either it may be a acid or base. They show the character of acid as well as basic. They are said to be amphoteric in nature. Yes, the dual nature of these salts we are saying as a amphoteric salts in nature because either it is behaving acid or a base. Example for these amphoteric oxides: zinc oxide and zinc hydroxide react with both acids and concentrated alkalis and forming a salt and water. See here, the zinc oxide is reacting hydrochloric acid and forming a zinc chloride and water. It's a neutralization reaction. Again, the zinc hydroxide also reacting acid to forming a corresponding salt and water. Next, the zinc oxide is reacting a base sodium hydroxide and forming a sodium zincate and water. So you see here it is reacting acid as well as a base and giving us salt and water. That's why we are saying this is amphoteric in nature. Amphoteric oxides and hydroxides are those compounds which react with both acids and alkalis to form salt and water. Next, here we are going to discuss some of the amphoteric oxides. First, zinc oxide and then zinc hydroxides. When it is reacting sodium hydroxide, it is forming corresponding salt, sodium zincate and water. So, the same thing is happening in the alkali zinc hydroxide with the sodium hydroxide reaction. Again, the zinc oxide with the potassium hydroxide. So, either it may be a zinc oxide, metallic oxide, or else a alkalis. Both are reacting with the one base, forming a corresponding salt and water. Our next oxide is aluminum oxide or aluminum hydroxide. Here, this aluminum oxide is reacting sodium hydroxide to forming sodium aluminate and water has been produced. Next, aluminum hydroxide is reacting caustic soda. Next, here the formation is sodium aluminate and water. The same thing is happened to the reaction with potassium hydroxide. Potassium aluminate is forming. The next thing, lead oxide or lead hydroxide. This is also reacting with sodium hydroxide forming a corresponding sodium plumbite and water. Then the same reaction is taking place with the lead hydroxide and then lead oxide also reacting potassium hydroxide forming a corresponding potassium plumbite. So these three only, aluminium, lead and zinc, these three only having a amphoteric nature. So either it's oxide or else hydroxide. They given acid or base. It is giving a corresponding salt and water. That's why we are saying as a amphoteric dual nature of salts. Here is your assignment. This lesson is over. It is a very small lesson. In this lesson, you will get questions based on the reaction with sodium hydroxide, ammonium hydroxide, and then reaction with metal oxides. So, depends upon the metal what color precipitator as we are getting, then which is soluble when we add excess ammonium hydroxide or sodium hydroxide. So these are the important things in this lesson. So you can learn this lesson carefully, because in this lesson only you'll get a much equations. So go through carefully. Next class onwards, I'll try to upload the lessons, because you didn't receive a book to the tab scanner. I'll upload the lessons. So side by side you can study that one also to prepare for your exams. If it is possible, try to log in Google Classroom. I'll conduct test, then only I can evaluate yourself. Four lessons are over. You can do a self-assessment to evaluate yourself. If it is possible, try to log in Google Classroom. I think few students only logged in that Google Classroom. Then only I can conduct a test. Even I too evaluate you people. Thank you, students. Have a great day.